Okay, good afternoon, everybody. I'm going to switch gears a little bit from NFV to SDN, and especially how do you control and manage large service provider networks, multi-domain service provider networks. So I'm going to first talk about, why does this matter? What are the things you could do with SDN? How do you transform your network through this technology? I'm then going to talk about how do we get there, the journey. As was discussed earlier, this is not something you can achieve in one step. What is the journey to get there and achieve value while you're at it? Then I'm going to switch gears from kind of the more high-level value aspect to the architecture. What is the emerging SDN architecture that we're seeing for service provider networks? And then finally, I'm going to address why we believe this is the right architecture. How is it better than other alternatives that have been discussed? So let's start with very high level. What is the impact of automation in the network? What are the key business indicators that can be improved through automation of the network itself? And it starts from making the network agile. Today, if you look at IP networks, optical networks, they're fairly rigid in how they're connected. They're not focused on the application, but rather on traffic and connectivity. And through automation, you can make these networks a lot more specific and to the applications, application-centric and on-demand. And this is key for the effort of making the service providers digital, like was mentioned earlier in the Swisscom talk. From an operational perspective, networks today are extremely process-heavy, extremely manual in how they're being run. I mean, people still use CLIs for a lot of things, extremely manual processes. And automation can transform those to networks that are really data-driven. They're driven by the actual state of the network and automated instead of manually operated. And from a capital expense perspective, today, because these networks are so operationally rigid and not agile, they're bloated. There's a lot more capacity in the network than needs to be, and therefore a lot more cost than absolutely necessary. So there's a chance to transform those networks to networks that are a lot more thin and lean, a lot less resources to do the same job, or actually an even better job. And there's also an opportunity to commoditize the network, move away from expensive hardware that dominates some of these networks to hardware that's a lot cheaper without bearing some of the consequences in terms of the cost of such transitions. So this is why automation is valuable in service provider networks. But this cannot happen over a day. I mean, a lot of service providers are in this situation on the right where they say, okay, there's huge benefits for SDN, but how do I get there? How do I make this huge leap towards SDN? And we believe in, we've architected our solution in a way that allows you to do this in small steps while you can get value at each step of the way. You start small, you get value, and then there's more momentum behind SDN, you can move to the next level. And to do this right, you have to first pick which use cases for automation are important for you as a service provider. And then you have to pick the right SDN architecture that allows you to achieve those goals in a gradual fashion. Then you have to sometimes enhance your network in terms of the actual gear and software, controlling the network to make it more automated. I mean, an example is optical networks, which can be switched and therefore provide a lot more value if once automation is there. And finally, once you've picked the use cases, you have the architecture, and you have the right platforms, you have to define the steps which will get you there and the value that you will get at each step of the way. So this is kind of the process that we see and we're working with our customers to achieve. I want to talk about two key use cases that we've identified that resonate with a lot of our service provider customers. The first one is around network uptime assurance. So ensuring that the service provider network assets are used in the most optimized way to achieve the resilience that these service providers want, not just when you install the network, but also throughout the life cycle of the network as it evolves and grows over time. The second use case is around fulfilling premium services and assuring them. And by premium services, I mean services that have tough SLAs. So, when you talk about connectivity, for example, from enterprises into cloud, right? One of the key use cases is extremely low latency, especially in countries that are large enough where latency is an issue, and services that where you have absolute diversity of your main and backup paths in the network, so that they don't fail at the same time. And surprisingly, in today's networks, you can't support services with such very tight SLAs. IP networks are just not built for that, and not in the way that they're operated today. So fixing that is another key use case for SDN and automation. So let me talk about each of those in a bit more detail. So the first use case is showing the uptime of the network. And I'm talking mainly about the uptime of the IP network. So today's mode of operation is an offline design. People design the network based on what they believe how traffic will evolve over time. They typically overbuild the network substantially. We're seeing typically utilizations of less than 20% on core networks on average, and that's because they overbuild it, not because they know that they don't actually understand the network extremely well. So they have to, as an insurance policy, if you will, they have to overbuild it more than absolutely necessary. And then basically the next step is to pray that whatever they have not misunderstood about the network does not cause major outages. And every service provider that we talk to has had, has scars on their back from major outages that take out whole cities because they did not fully understand the network. So, you shoot an arrow and you're not quite hitting the target. And that's with this huge investment that you've put into the network. The process we're offering, and it's doable with automation, is a much more controlled process, a closed loop control process, which is kind of more like a guided arrow to the target. And it's about first accurately discovering all your network assets and your network state, exactly what's connected to what, where is traffic going, etc. Automated planning based on the actual knowledge of the network. Deployment that's, again, as automated as possible, as accurate as possible. Measurement of how well the network is currently protected, and adjustment of the network. So this is the closed loop aspect of it, of adjusting the network and where you deploy assets in the network to actually achieve the level of protection you need given the current traffic situation in the network. So this is the example of how you improve uptime of the network with actually lower cost than today's practice. The second example I wanted to give is around fulfillment and assurance of services. Again, I'm talking about business services with extremely tough requirements in terms of capacity, latency, diversity, things of that nature. And today's approach that we're seeing in most service providers is overpromised. They tell the customer, yes, we can do it, while they can't really. They don't have the infrastructure to actually ensure that this is the case. Overbuilding the network, again, hoping that if there's enough capacity, somehow the network will find paths through it which don't have too much latency and will not cause problems in the customer. And then there's limited assurance tools which are not quite automated that kind of give you some indication of the state of the service, but do not quite guarantee that the SLA is met. Our approach here is very similar at a high level. Obviously, a lot of details are different, but at a high level, again, it all starts from understanding the network. By having a good understanding of your network, you know what's feasible and what not. You won't just promise I can give you that service with this capacity. You know if it's doable or not. Again, planning which is as automated as possible. Deployment of capacity. This time to meet not just reliability goals, but the actual service needs. You know that this bank needs this much capacity here, so you're going to deploy capacity to achieve the specific needs of the services. Measure how these services are actually doing. Are they actually achieving their goals? And taking corrective action if not. So rerouting services to shorter paths, rerouting them to achieve diversity if it's currently violated. So it's an active process, closed loop process to assure that these services can be can achieve their actual promised SLAs. So in both of these cases, we're replacing an open loop, deploy and pray kind of mentality with a closed loop accurate measurement, and correction approach, and to achieve these goals. Okay, so this was kind of why do we do SDN and how do we do this? And one thing I perhaps should have mentioned is that the process here, if you look at it from right to left, is actually gradually deployable over time. So you can start by just read-only capabilities where you measure, understand your network, recommend changes without actually closing the loop in an automated fashion, and you can increase the level of automation as you as the service provider are more ready for more automation, because it's really somewhat of a psychological process as well. You need to trust the solution before you can close the loop. So it's deployable in steps from that perspective. So let's talk about architecture a little bit. So this is the architecture, the emerging architecture we see in service provider networks. Starting from the bottom, perhaps, you have the customer premise equipment on one hand, the data center on the other hand, and then the network in the middle. And the network is not monolithic, right? It includes IP domains, optical domains from different vendors. They're all managed separately today. There's really no coherent view of the entire network. Each of those, in a world of SDN, will have their own controllers that kind of are concerned with the specifics of their domains. And you'll have multiple controllers typically per vendor, at least on the network side. On top of that, there's a network controller function, which is a function that unifies the entire network, takes all these disparate domains, puts them together, and on top of that, and this is really the level of, that's the function that really understands the network end to end. And on top of that, you have service orchestrators, typically multiple orchestrators, at least that's what we're seeing for different use cases, different types of services, and these are more OSS functions. They're functions that are concerned about end-to-end service from data center to CPE through the network, but the network is not their main concern. And then a bunch of OSS tools on top of this. So I'm going to focus on the orchestrator, controller, and network controller and domain controller. And really, the orchestrator is concerned about the end-to-end service life cycle. I'm, chaining VNFs in the data center to achieve some combination of functionalities. I'm provisioning something in the CPE, but I also need to worry about the network itself, especially, again, if the service requirements are tough. I can't just ignore the network as underlay, which is what people do today. I need to actually make sure that the network understands that this service needs to be low latency and needs to have this level of diversity. So the service orchestrator doesn't want to be bothered with network details. It just wants an abstract view of the network, but it needs to understand a lot more the end-to-end service aspects. Okay. The network controller function is the stuff that really puts the network together. It understands the different domains, puts this whole puzzle together, understands how everything is connected, understands what are the resources that do not belong to any of the domains, but rather are the inter-domain connectivity between IP domains, between optical domains, across different layers. And it abstracts that complex network structure to the orchestrator so that the orchestrator doesn't have to worry about network details. And again, most orchestrators don't want to worry about network details. And it provides us a single pane of glass for network engineers to understand what happens in the network end-to-end. Now, and obviously, when you get to more sophisticated functions like optimization, restoration, again, that's the function of the network controller. Domain controllers are actually quite similar in the level of sophistication they need, but they're domain specific. So you might have a Cisco IP domain controller that understands the IP layer very well, better than anybody else, especially for Cisco technology, but it's confined to the Cisco domain. Or a Sienna controller, which has a lot of sophistication in terms of understanding the Sienna optical network, but it's confined to that domain. So these controllers need to be sophisticated, but specific to the domain. Luckily, if you look at, or maybe as expected, if you look at the different standard bodies, and I try to align here IETF, ONF, and MEF, you see those layers there. So it's the standards are really supportive of this three-tier structure of orchestrators, network controller, and domain controllers. And now with the remaining time, I want to go through some examples of why we believe this is the right architecture. But before we do that, let's think what does the right architecture have to achieve. So first, the whole point in SDN was avoiding vendor lock-in. You want to replace your vendors. You want to based on your actual needs. So avoiding lock-in is a key requirement of a good architecture in this world. You want to ensure that each vendor is motivated and able to advance the solution. The vendors that, if they don't have anything in it for them, will not do their piece of the puzzle, and that's not a viable architecture. You want to minimize the impact of innovation to the minimum number of components. If you upgrade your IP network to include segment routing, you don't want everything, all these layers, to understand that there's been a change in the network. You want to be able to innovate but not reintegrate the whole solution as a result. And importantly, you want bugs and security issues in one component to stay within that component. So you want the network to protect itself from security issues spreading up this stack of these components. This is especially important because we're talking about centralized architecture. So if you hit kind of the whole structure, then the network is really compromised. So let's take a few examples. So some people are advocating combining network controllers with the domain controllers. That's a bad thing, because then if you want to replace that vendor, you're not happy with that vendor, you'll have to reintegrate a lot of interfaces to all the domains, to all the service orchestrators. You get vendor lock-in. Fundamentally, you can't replace this component in the network. And that's wrong in this architecture. Other people are trying to come up with technologies that span the data center and the IP layer together, so kind of trying to achieve value at both layers. That's nice, but then you can't buy some other vendor's equipment for the data center and for the network. And it's effectively also vendor domination of your network, and that may not be a good thing for you if you're worried about vendor lock-in. Another example is trying to integrate service orchestrator and the network controller. So one big controller and orchestrator as one big beast. And that violates the second point that we made, which is not many vendors are able to play in both of these roles. This is fundamentally different expertise. OSS type service assurance and fulfillment functionality compared to network knowledge. And so it limits the number of vendors you can pick from, plus you're probably not going to get best of breed if you do this, if you take one vendor to do both for you. Another thing often pushed by some of the large vendors is, we'll take the network, the network controller, the domain controller, and the network itself. We'll do, it's one piece, easier to buy. That's true, but if a big equipment vendor does that, the other vendors will not play along nicely, because fundamentally you get your biggest competition with full visibility into your own network, and that's not going to fly in terms of collaboration between. So the ecosystem is not going to work well with this. Another example is, so far I pointed out negative examples. You see this red X here. A few positive things. It is actually very good for the IP controller and for the domain controller and the domain itself to be from the same vendor, because then the vendor can introduce innovation more easily. A lot of times it's easier to innovate at the controller level. Furthermore, they're motivated because it improves their ability to sell hardware, which we all know is ultimately their bigger business. So those two together is actually a good thing. Likewise, if you keep the AP the controller and the actual equipment together, then innovation is confined to that. So you can innovate in the network. The IP controller might have to change, but you can kind of complete the testing and the integration within the vendor domain. You don't have to reintegrate or retest the other layers. I'm not going to go through all the, maybe just one more point is that if you, like some people are trying to do with like some big open software to integrate everything into one big piece of software, then a bug or a memory leak or a security breach somewhere impacts everything, and that's a very dangerous thing in our opinion. So we believe in separate components with clear APIs between them, also from a security perspective. So these were the kind of some of the considerations that we believe are important in the context to keep in mind. To summarize, we don't think believe that SDN shouldn't be thought of as a long-term end goal, rather the journey that you can start today. You want to focus on use cases that are good for you as the service provider, and pick an architecture that will motivate the ecosystem to work with you to advance the architecture, not hold back on it. Finally, if you have more questions, comments, visit our booth, B37, and you'll see this technology in action. Thank you very much. Okay, no time for questions.